Optical property, absorbance, exploring how light plays a significant role in various applications, including research, quality assessment, and process control. Three types of optical properties. First is transmittance. Transmittance of light is a measure of how much light passes through a material without being absorbed or reflected. It is defined as the ratio of the transmitted light intensity to the incident light intensity. Second is absorbance. Absorbance of light is a measure of the amount of light absorbed by a material as a beam of light passes through it. It quantifies how much light is not transmitted through the material, and it is an important parameter in fields such as chemistry, biology, and material science. Lastly, reflectance. Reflectance of light is a measure of how much light is reflected off the surface of a material. It is defined as the ratio of the reflected light intensity to the incident light intensity. What is absorbance? Measure of how much light or electromagnetic radiation is absorbed by a substance as it passes through it. Plays a significant role in various applications, including research, quality assessment, and process control. It is also known as optical density odd, is a quantitative measure of the amount of light absorbed by a solution at a specific wavelength. It is a dimensionless number that reflects how much of the incident light is absorbed by the sample rather than being transmitted through it. Importance of absorbance. Quality control in food and beverage production. Quality control in food and beverage production is critical to ensuring safety, consistency, and quality of products. One common method used in quality control is the measurement of light absorbance, which can provide valuable information about the composition and characteristics of food and beverages. Sorting potatoes using light sensors is a modern, efficient, and precise method that enhances quality control in the agricultural and food processing industries. This method primarily utilizes optical sorting technology, which employs light sensors to detect and sort potatoes based on various attributes such as size, shape, color, and defects. Monitoring crop health. Monitoring crop health using light absorbance is an effective technique that provides valuable insights into the physiological and biochemical status of plants. This method primarily relies on the interaction of light with plant tissues, particularly how plants absorb and reflect different wavelengths of light. Monitoring crop health using light absorbance is a powerful approach that integrates advanced spectroscopic techniques with modern agricultural practices. By providing detailed, real-time insights into plant health, this method supports precision agriculture, enhances crop management, and promotes sustainable farming practices. Environmental monitoring. Environmental monitoring using light absorbance techniques is a critical component of assessing and managing the health of various ecosystems. These methods enable the detection and quantification of pollutants, the assessment of water and air quality, and the monitoring of ecological changes. Environmental monitoring using light absorbance refers to the practice of assessing and quantifying environmental parameters by measuring the absorbance of light across different wavelengths. This approach leverages the principles of spectroscopy to analyze the interaction between light and environmental samples, such as air, water, soil, and vegetation. By measuring the absorbance patterns of these samples, researchers, environmental agencies, and policymakers can gain insights into various environmental factors, including pollution levels, ecosystem health, and the impact of human activities on natural systems. Research and development. Research and development in the context of light absorbance techniques for plant phenotyping, breeding, and environmental monitoring involve advancing technologies, improving methodologies, and discovering new applications. Phenotyping and plant breeding. Phenotyping and plant breeding using light absorbance techniques involve the use of spectral properties to assess various plant traits. These methods enable the non-destructive, rapid, and accurate analysis of plant characteristics that are crucial for breeding programs aimed at improving crop performance, disease resistance, and other desirable traits. Phenotyping and plant breeding using light absorbance techniques involve the use of spectral properties to assess various plant traits. These methods enable the non-destructive, rapid, and accurate analysis of plant characteristics that are crucial for breeding programs aimed at improving crop performance, disease resistance, and other desirable traits. Importance of absorbance. Detection of pesticides and contaminants, absorbance spectroscopy. Detection of pesticides and contaminants in food and beverages using absorbance spectroscopy is a crucial aspect of ensuring safety and compliance with regulatory standards. Absorbance spectroscopy, particularly UV spectroscopy, is widely used due to its sensitivity and specificity. Absorbance spectroscopy is a crucial analytical technique used to measure the amount of light absorbed by a sample at specific wavelengths. Based on the Beer-Lambert law, it helps determine the concentration of substances by correlating absorbance with concentration, path length, and molar absorptivity.